Okay, the stream is going. Let's see, here we go. Good afternoon, everybody, and welcome to day 2 of the 2021 Virtual Christmas Summit brought to you by Boscoyo Studios. This presentation is sponsored by Wired Watts. And some brief housekeeping. Please don't unmute or interrupt the presenter. Feel free to put any questions or comments into chat. I'd like to present this morning Rick Harris, who will be talking about FPP installation and configuration. Go ahead, Rick.
Alrighty, welcome guys. Like you said, if you got any questions, there's probably going to be a ton of questions. Post them in chat. We've got a couple people that'll probably answer most of them in there. But I will have some question and answer sessions along the way if there's any issues that you come across. So this class is the step-by-step FPP installation and initial configuration for you people that want to learn how to install FPP or even some other methods that might be beneficial. So my name's Rick Harris. I'm from Meridian, Idaho. I've been doing animated lighting for 4 years. I do not have a technical background, so I've learned all of this new. I'm the author of the FPP manual along with assistance from Mark Amber. I conduct year-round testing and quality control for FPP, and I'm currently retired, so all I do is goof off. So the installation of FPP is fairly straightforward. We're going to go step by step and install FPP on your device and get you up and running. If you're going to be following along, you should have already completed the checklist that was provided in the class schedule. But if you haven't completed the checklist, then you'll have to do your best to keep up if you're going to do the follow along, because we're going to download some files and that can take some time depending on your computer and your network. You don't need to you don't need to be participating in the follow along process to learn from this class, and this will help you for when you're actually ready to install FPP. I've got several question and answer sections at the end of each section, so if you have a question, there'll be an opportunity to ask them, and I'll hang around at the end of the class for questions as well. To install FPP, there's a few things that you need to prepare and consider before you start your installation, and some programs and files that you'll need to download to complete the installation. There are 3 methods of installing FPP. They'll all give you the same results, and which method you use will depend on a few factors. I'll demonstrate the installation on a couple different devices, and hopefully that'll get you what you need to do. To install FPP, you do not need to connect an external monitor or keyboard to your FPP device. I get a lot of people that do that because that's how normally you'll work with a Pi, and it ends up just confusing them. They're not used for the installation. All functions and communications with FPP are handled through the web interface that you access from your computer. After FPP is installed, we'll go over the initial configuration of your FPP device. In order to install FPP, there's a few things that you'll need to have prepared before you install FPP. And if you downloaded the checklist, you should already have the necessary items. The first thing you're going to need is a good quality micro SD card. The SD card is the heart and brains of your show, so don't skimp on the card. There's 2 important things that need to be considered when you purchase the SD card. The first is the file transfer speed, and the other is temperature rating. You'll need at least a class 10 rated card for the speed, and most FPP devices are in an enclosure with a power supply, which can create higher than normal temperatures, and many are installed outside, which can cause unusually low and sometimes high temperatures. I'd recommend either the SanDisk Extreme or the Samsung Evo Select cards. You'll probably not need anything larger than a 16 gigabyte card, but sometimes a 32 gig or 64 gig card is easier to get. I don't recommend getting anything larger than a 64 gig card because you'll probably never need that much space. In reality, a 16 gig card will probably give you way more than you'll ever need. With a good quality 32 gig SD card running around $10 or less, there really isn't a reason to skimp on this, especially because that is, like I said, the heart and brains of your whole show. Also, when you're purchasing SD cards, be careful of online vendors, especially like eBay, because there's a lot of counterfeit SD cards floating around that don't have the speed rating that they state, or the capacity. Depending on your computer, you might need a micro USB card adapter just so that you can access it. Here's a diagram showing how SD cards are identified in case you want to look at it. Anything with the 10 megabytes per second is considered a class 10 card. So anything at this level or above would be sufficient for the speed. Anything, going above it isn't really needed. You're not going to gain much benefit by using it.
Can I jump in there real quick?
Yeah.
Can you head back? One of the interesting things about SD cards is they're all rated by their write speed. So if you take a look at these are how fast you sequential writes. And that's not something that we actually do much, except for when you're uploading sequences. So it's more important for us is actually being able to read quickly and random access to the files off the things, which is why we strongly recommend the SanDisk Ultras or Extremes or the Samsung Evos, because they have an A1 rating, which isn't even mentioned on here, which is designed for application use, which is much more the usage pattern that FPP uses.
Cool. Thanks for that info.
Yeah.
Okay. The next thing is you're going to need to know what the IP address is on your router. You can usually get this by going to a command prompt on your computer and typing in ipconfig on Windows-based systems or ifconfig on Macs. It'll usually be listed as the default gateway for one of your network devices. Some of the more common ones are 192.168.0.1 and 192.168.1.1. And this is what it'll look like. So if you see here, I did an IP config, and down here it shows the network that I'm connecting on. And my default gateway is 192.168.1.1. That's the address of my router that this network is connected to, because I'm connecting to it through Wi-Fi. One thing I want to mention here is if your default gateway is 192.168.6.7 or .8, you're probably going to have some network problems because those subnets are defined internally either by the BeagleBone systems or Windows and Mac systems for internal devices, or internal communications, some for USB tethering. So those subnets usually can cause problems, and especially like the Euros that are default to a .7 subnet, that could cause you some problems. So if your gateway is 192.168. either 6, 7, or 8, you might want to think about changing your network over to that, which isn't that difficult to do, so that you can continue with your communication. Then you're going to need to decide how you're going to configure this in the final network. Depending on how you are going to communicate with everything, it's going to vary slightly how you're going to configure your network. So you kind of need to know ahead of time how you're going to use it so that you can configure the network. You're going to need to install some software. You're going to need an SD card formatter. You don't want to use the Windows or Mac native format systems, because they a lot of times can leave partitions or other files in there. You want to totally wipe it before you start. Then you need an imaging program, so you can use Balena Etcher or .NET Disk Imager. .NET Disk Imager does have a wipe function in it, and I've heard that Balena Etcher will wipe the card, but I haven't verified that. Then you need to get the FPP image for your particular device. So many times I see people trying to install FPP and they have no idea how they want to use FPP in their network. And that causes some problems because they don't know how they're going to configure it. And if they don't know how to configure it and how it's going to be connected to the network, you don't know what settings you actually have to do, and depending on how it's going to communicate, those settings can be different. If you don't, so you need to decide this before you actually start the installation. If you don't know how you're going to use your FPP device at this point, then I'd suggest just using the easiest network configuration, depending on your device and your current connection, and just set up FPP accordingly. During the initial installation of FPP, you're going to have to configure some sort of network in order to get your FPP device, in order to connect to your FPP device once it's set up. So I'm going to go over some networking basics because many people have a hard time configuring their networks. So hopefully a basic understanding might help, especially when you get into a little more advanced network configurations to make your show run more efficiently. There are a few concepts I'll present, and these are just basic concepts, and I hope it'll make things a little bit clearer. So a network is basically just a bunch of connected devices, and think of them kind of like houses with telephones. And then you can even have a network within a network, like you have cities within states. But this telephone system has some slightly different rules they have to live by. I'm going to show you an oversimplified review, but this should give you a fairly good understanding. The first thing is how IP addresses work. The second is how devices in one subnet communicate with devices in other subnets. It's kind of like using your phone calling someone that's out of the area. And then how a network uses host names to reach other network devices. But networking can get confusing at times, and the concept can be a bit overwhelming. If one part of your network isn't configured correctly, then you can get partial communication or no communication at all. And it can become real frustrating, especially if it's only a portion that isn't working because you think it's configured correctly, but something isn't working. But that could just be because only a part of it isn't working. If you have a little understanding of how networks work, then at least at a basic level, you'll have far fewer problems than other people do when getting it configured. But then I might just confuse you more, but I hope not. If after this class you're confused, let me know and I'll try to help you out. All devices in a network have IP addresses. Even servers on the internet like Google and Yahoo have IP addresses. An IP address is how each device is identified. It's basically their name. And each device in a subnet obviously has to have its own IP address. You don't name all your kids with the same name. Otherwise, it'd be difficult if you want one of them to do something. The IP address is basically 4 sets of 3-digit numbers separated by a decimal point, and each set of 3 digits cannot be larger than 255. So an IP address will be something like 192.168.0.1. A subnet, which is defined by a net mask, which we really don't need to get into, it's like an area code. And a subnet is defined by the subnet mask. And in most networks, the first 3 sets of numbers in an IP address is the subnet. So in this network, you could see that the subnet is 192.168.1. All the devices in that network start with the first 3 numbers of 192.168, and then the last number is the device number in that subnet. So the first one has a device number of 5, second one is 8, and all those devices can communicate directly with each other because they're all within the defined subnet. If configured correctly, all devices can talk to any other device in the same subnet, but they can't talk to devices in other subnets like the internet without some other configuration. It's kind of like your phone has to dial an area code to get to a different state or area code before you dial the numbers. But networks don't have area codes to dial, they use a whole different method. So if a device on your 192.168 subnet tried to contact a device on a 192.168.2 subnet, without the additional configuration, it wouldn't fail. It doesn't know that 192.168.2 network exists or even how to get to it. So, like I mentioned before, basic network devices can only communicate directly with other devices that are on the same subnet as their own. And they have no knowledge of any other network if it exists or what their IP range is. In order to communicate with another subnet, like getting to the internet, you need some additional hardware. this hardware is typically a router, and that router is also a gateway. A router actually has two network interfaces combined together. They're just in the same package. Each network interface will have a separate IP address, and that IP address will be in a different subnet than the other interface. Your router has a LAN network, and LAN stands for Local Area Network, and that is usually your home network, and all devices in that network will have an IP address in the same subnet as the router's LAN IP address. So in this case, they'll all have an IP address that starts with 192.168.1. That's your local one. Your router also has a WAN address, which stands for Wide Area Network, and that's what goes out to the internet. It has its own IP address as well, and this IP address is usually part of your internet service provider's subnet. All traffic going out of the WAN port is managed by your internet service provider. One of the functions of a router is to process incoming data requests and then route them, hence the name router, to the correct WAN or LAN interface. The router will get incoming data from both the WAN side and LAN side, and it needs to decide where to send the traffic, and that's based on rules that's built within the router. But in the broad sense of things, it's fairly simple. The router has a bunch more functionality, and I'll touch on a small portion of that a little bit later, but basically it just sends the traffic where it needs to go. Most network devices have a setting which is called a gateway. A gateway is the IP address of a device that can process and route traffic that is not in the same subnet as the interface that it's trying to communicate with. So if you're trying to communicate across different subnets, that's where a gateway comes in. That's typically going to be your router, but in our lighting hobby, it's sometimes an FPP device. FPP devices do not have all the ability of a router, but they can be configured to bridge network traffic between different subnets and be used as a gateway. Each network device should have the correct gateway defined, but not all of your devices will use the same gateway address than the other devices in your overall scheme of things. And you'll see why in a little bit. Remember I said that network devices can usually only communicate with devices on its own subnet? Well, because of that, the gateway has to be on the same subnet as the interface that's being configured. So if you're configuring a device with the subnet of 192.168.1, then your gateway has to have an IP address in the same subnet of 192.168.1. The basic process is that when a device sends out data communication to an IP address that's not on its own subnet, it doesn't know how to handle it. So it will send it to the gateway that's defined, and then the gateway will process that request. Let me demonstrate how this works. This is one of the more common lighting configurations. In this configuration, we have an FPP device that is connected to your home network by Wi-Fi, and that FPP device is hardwired to a network switch. Then all of your controllers are hardwired to the network switch. And in reality, if you only had one controller, then you won't need the switch. Your home network is in the 192.168.0 subnet. You see that there. And in the router and computer and the Ethernet side of the FPP are all in that same subnet. They all have the first three numbers of 192.168.0. Your controller and the ETH0 side of your FPP device are all on a different subnet than your home network, and that is 192.168.101. And you've got 101.2 for the FPP and 101.3 for your controller. This is typically referred to as having a show network. So you access your controller that has an IP address of 192.168.101.3, and you want to update it. And you're using 8.8.8.8 as your DNS server. We'll get into that a little bit later. The controller sees that this address is not in its subnet of 192.168.101. So it doesn't know how to handle it. So it passes it on to its gateway, which has an IP address of 192.168.101, which is within its subnet, so it can communicate. .2. So it'll pass that on to its gateway. The network switch gets it, and it simply passes it on to its destination of 192.168.101.2. And then the FPP device, it receives that request. It sees that it isn't on its ETH0 subnet or its WLAN 0 interface. So it passes it on based on the rules to its gateway, and it has a gateway identified as 192.168.0.1, which is your router. The router receives the request and sees that it isn't on its local area network or its wide area network, which is the 192.168. I'm sorry, 192.168.0.1 or 184.57.99.152. So it passes it to its gateway, which ends up sending it out to the internet. So you can see how the gateway would be an important part of but if your data never needs to cross into another subnet, the gateway would never get used. But it's important that you define it and define it correctly. Let's take another example. The gateway on the controller is configured for the address of the home router, which is 192.168.0.1. So the controller is trying to update by reaching the DNS, the same scenario, but because the gateway is not in the same subnet as itself, it has nowhere to send it to. So it dies. It doesn't go anywhere. So it has a gateway that can act as a gateway, but it's not within its same subnet, so it can't communicate directly with it. So you can see that the gateway can be an important part of your network configuration, and each device has to have the correct gateway configured in order for traffic to flow through the network. But not all the devices in your network are going to have the same gateway. It's going to depend where it is in the chain. So most networks have a host name. A host name is a name that makes it easy for us humans to remember. Websites are exactly the same. They're hosted on a server, and those servers have an IP address associated with them, just like our FPP devices. But most people wouldn't want to type in 172.217.14.238 to get to google.com, which that is their address, because it's easier to remember google.com instead of all those numbers. All network communication is handled through IP addresses. They don't send google.com through the wires, they send the IP address. You can use the host name to access your FPP device in the same way you access websites. Just put a / after the host name to force it to not try to connect to the internet. This is a feature that many people don't use, and I think it's either because they don't know that it exists or that they don't have the network configured correctly and it didn't work for them. Some programs will actually use host names in referencing your FPP device, so it's highly recommended to have this configured correctly as well. Because many times a DNS server's IP address is not in the same subnet as the FPP device itself, then it's very important that the gateway on all the devices is configured correctly, as you saw earlier, because it might not get to its final destination of the DNS server. How this works is there's some devices that have a system similar to a phone book. Just like if you're wanting to call Santa Claus, you grab a phone book, look up his phone number, and you'd see the number, and then you'd enter that number in and call him. A DNS server is basically the same thing. Your network device will send out a request to the DNS server for the IP address of a certain host or domain. If the DNS server is reached, it will return the IP address, and then your network device can then send out its data to the IP address it received. Remember, I said they don't communicate by the host names, it's all through IP addresses. For your system to work properly with host names or programs that use host names, there's a few criteria. First, obviously, is the IP address configured for the DNS server actually goes to a device that can handle DNS requests. Second is that the DNS server can be reached. If you don't have the gateway and other stuff configured, it won't reach it. So there's basically two types of devices that can handle DNS requests. The first is your home or show router. Most routers are configured to handle DNS resolution for your local area network site. It'll keep track of your local network, and most routers will forward any request for domain names to the DNS server that your ISP has established. Second is an internet-based DNS server, and there are literally hundreds of them. One of the more popular ones is 8.8.8.8, which is Google's DNS server, and it is popular because it very rarely goes down. But another popular one, but not as well known, is 1.1.1. So is there any questions on the preparation and networking basics? Let's see. So somebody asked if there's a recommended list of FPP devices. In the FPP manual, there is. Right now, it's pretty much every BeagleBone device with the exception of the BeagleBone Green Wireless and all of the Raspberry Pi devices. Oh, and I see somebody mention that. Okay. Any other questions? Everybody good? All righty. So there's several methods that you can use to incorporate your FPP and controllers into a network so that they can communicate with each other. There are four basic type of network configurations used in our hobby, but a lot of times people will use a combination of them, but you need to understand how the basic one works first before you can implement it. The simplest method is to incorporate, which is wired on your home network. This is where you connect all of your FPP devices and controllers directly to your router via network cables or even Wi-Fi communication. This configuration is simple to implement and configure and the easiest way to get started or to use just for initial configuration or testing. So you see everything is connected in some method directly to your router. The first drawback is that depending on your network and the connected devices, your show might exhibit some lag if you get to a little bit larger size. For a lot of displays, this won't be an issue, but if you get a little bit larger, it might. Or if your network already uses a lot of bandwidth, like streaming videos, then it can be an issue. The second issue is you might not have enough ports on your router to connect all of your devices, but that isn't a major concern because it can easily be remedied just by adding a switch. This is the same type configuration, just added a switch, and now you have a whole lot more ports to connect to. For most cases, an unmanaged 10100 switch will work, but larger displays might need a faster switch. This is a fairly simple addition to add, but it doesn't alleviate you from the issue of the network traffic if you have a large show or your network can't handle the network traffic it's processing. The next method is a wired show network connected, a wired with a separate show network. So this type of network is where the show network components are wired together through a switch and an FPP device is used to bridge the network. You see that all your controllers over here on this side, they go up to a switch and then they go through the FPP device and the FPP will communicate wirelessly to your computer and router. The main FPP device will have the Wi-Fi IP address in the same subnet as your router, and the Ethernet interface will have an IP address in a different subnet, and all of your controllers will be on that subnet as well. This configuration has some advantages. All of your show network traffic is on its own network, so it doesn't interfere with your home network. And with the FPP device bridging the two networks, your show devices all have access to the internet for such things as updates. And if you only had one controller, you wouldn't need a switch. You just wire it directly from the FPP directly to the controller. Another method is wireless. There's really two types of wireless networks that you can configure. The first one is essentially the same as the others, except instead of an Ethernet cable transmitting the data, you'd configure your wireless interface to transmit the data. But this isn't a recommended method because it really doesn't take much in our hobby to get enough data channels that causes congestion in your network. The second wireless method is the master remote method of a wireless network, and that's a mode of communication. This is a very popular method used. It's a method that I use in my display, and that's where you have all of these different devices. They all communicate wirelessly with each other. The data traffic is very minimal, so it really doesn't have an impact on networks. A common misconception and mistake that people make is they think that if there's more than one FPP device in your show, then you're running a master remote configuration. That's not necessarily correct. Master remote is a mode, and it's a method of communication. It has nothing to do with the number of FPP devices in your show. If you have your main FPP device and all of your other FPP devices connected to a switch and sending the sequence data from your main FPP player to your other devices, then you're not running a master remote mode, you're running in standalone mode. In this network configuration, the master does not send out the complete sequence data. Instead, it sends out relatively small sync packets, basically telling the remotes what sequence they should be playing and what frame in that sequence it is on. Like I mentioned, the network traffic is very minimal in this configuration, even for huge shows. This method works very well as long as you have a good Wi-Fi signal, and it is awesome for large, widespread shows or things even for like an entire street. Using the master remote mode, you don't need data cables running all over the place. With this method, your controllers become a lot more modular. For example, I have a Tune-To sign. It only has a plug coming out of it for power, and I unplug it, I'll move it to a different part of my yard and anywhere I want. And all I have to do is just connect power to it, and it works. This method does require an FPP device at each remote location, and each remote will need a copy of the sequences. There's a lot of controllers that are FPP based, such as the Cope Lights line of controllers, so you don't need an additional FPP device for those locations because they already have it. With the FPP Connect feature in X-Lights, it's a real simple process to keep your master and all of your remotes up to date. These are just the basic network types, and it's common to combine different types of networking together, but that's a little more advanced, and if you understand the basics, adding the others in isn't that difficult. If you're not sure how your final network is going to be configured, I'd suggest to just use the wired on home network method. So depending on your FPP device and your network configuration, you'll have to decide which installation method would be best for you to use, and you might have more than one option that'll work. Your installation method is different than your network configuration. It is not recommended to connect your FPP device directly to your computer using an Ethernet cable, as that requires changing some network settings on your computer, and it usually complicates things. The USB tethering method is probably the easiest because all you need is to connect your FPP device to your computer using a USB cable. The computer will supply the power to your FPP device as well, but there's only a few of the SBCs, which is single board computer, that support the USB tethering method. The Raspberry Pi Zeros and all the BeagleBones support USB tethering. The network installation method is probably the most commonly used method because any FPP device that has an Ethernet connection can use this method. The Pocket Beagles and Pi Zeros do not have an Ethernet port, but you can add a USB to Ethernet adapter easily and it works just fine. You'll then connect your FPP device into your existing network to either a port on the router or to a port on a switch that's connected to the router, and then add the proper power source to your device. One thing to mention on the USB tethering I want to talk about is that a lot of times there's a lot of devices out there that are using USB for power, and there's a lot of charging only USB cables around. So if you're having a problem with the USB tethering, swap out your USB cable, because it's not quite possible you might have a charging only cable. So Wi-Fi tethering is another useful method of installing the software. Any device that has a Wi-Fi adapter that supports Wi-Fi tethering can use this method. The devices that have onboard Wi-Fi adapters, like the Raspberry Pis, usually support Wi-Fi tethering, but there are not many Wi-Fi adapters that support Wi-Fi tethering at this time. Dan Culp from culplights.com usually carries USB Wi-Fi adapters that do support the access point or AP functionality that you need for Wi-Fi tethering. This is probably the easiest method to install the software on the Raspberry Pi Zero W, but it's also a great way to configure the Raspberry Pis as well. I actually like this if I want to just do something testing or get into it real quick. I don't have to hook up anything to the network. I just power it up, let it default to the access point, and then I can get into it and do the configuration. So at this point, you'll need to decide which method will be the best for you. We can't do a follow along using the Wi-Fi tethering option, because to do so, you have to connect to the access point and it'll disconnect us from Zoom. So I'll demonstrate the Wi-Fi tethering for future use and for documentation. If you're using a Pi Zero W, then I can go over this one-on-one later after the demonstration, because like I mentioned, Wi-Fi tethering requires us to log off of Zoom. Any questions on the preparation process for the installation? So somebody mentioned, I've always been said that the full Pis don't do tether.
Been sad.
Yeah. So, well, the tether, there's two tetherings. There's a USB tether, which the full Pis don't do the USB tether, but the main Pis do handle the Wi-Fi tethering quite well.
Yeah, I meant to say USB tether. It's so simple. I love it.
Yeah. Okay, cool.
No, yeah, you're doing great, Rick.
Thanks.
Real quick before Rick goes on, if you go in, for those of you that are using the full Zoom app, if you go into the participants tab at the bottom, there's some check buttons: yes, no, go slower, go faster. Can I get just everybody? How many people are new to FPP? Just click on yes or no, so I can get a count. And Rick, you can go on. I'm just curious to see how many new people we have. So if you're new, click on yes.
Okay, cool.
Thanks.
Okay, so you should already have the correct image for your FPP device if you're following along. For those that are just here to learn, I'll go over the process, but we won't have time to wait for you to download the needed files. The first thing you need is to get the correct image for your FPP device that you're going to be using. To get the image, you'll need to go to the GitHub site and the FPP releases section. This will list all of the releases available, along with the information about each release and upgrade instructions. It's recommended to use the latest release of FPP software and to update it to the most current version. That way you get all the enhancements and bug fixes. The developers are very good about resolving bugs, so I wouldn't worry too much about that. About the only time I would not recommend updating the software is once you start displaying your show for the year and everything is working correctly. And I mean just like the holiday season, not necessarily the year. It's always best to update to the most current if you can. But if you're in the middle of a show and everything's working, I wouldn't update. The latest release will be identified as such next to the listing. You should read the upgrade instructions in case there's some special requirements or methods needed. That usually is not required. It's usually a pretty seamless, basically you click, upload, and you're done. Sometimes the assets section will be collapsed, so you can't see the actual files. So just click on the word assets to expand that listing. You'll then click on the file that you need for your FPP device. If you're using a Raspberry Pi for your FPP device, then download the file that says pi.image. If you're doing BeagleBone, download the one that says beaglebone.image. This will save it to the location you specified, and make sure you pay attention where it's downloading it so you can find it later. I've helped people and they forgot where it was and they're searching all over trying to figure out where it downloaded to. So the first thing is you'll need to totally wipe the micro SD card and format it before you install the software. Don't use the Windows or Mac formatting programs because, like I said, they don't always wipe the card totally. You should have already installed one of the following programs. SD card formatter. This is a bare bones card formatter easy to use, or .NET Disk Imager. It's also a good imaging program, and it can wipe the card. And like somebody mentioned, they said that Balena Etcher does wipe it. I just did not verify. So at this point, open whichever program you downloaded and insert your SD card into your computer. There's my thought I had it open. I had to open it. So here's the SD card formatter. So you would identify the card if you have. I got two. It's going to be my F drive. And really all you need is a quick format, and that'll work it. If you're using files are disappearing. I had .NET Disk Imager open. Okay, and if you're using .NET Disk Imager, it's very similar. Select the card and click on Wipe Device. It'll give you confirmation. You say yes. If you're using .NET Disk Imager, don't close it because we're going to be using it here in just a minute. So at this point, we're ready to burn the image. Your micro SD card should still be in the computer. Open up the program that you installed to image the card, that you used to image the card, either Balena Etcher, or if you use .NET Disk Imager, it should still be open. So we're going to burn the card. I'll start with the .NET Disk Imager. So we're going to select the image file. In this case, I'm going to use a 4.6.1 Pi image. Select your SD card. You're going to select Write to Device. I'm going to ask you for confirmation. You say yes, and it's going to write. If you're using Balena Etcher, it's going to be essentially the same thing. Going to select your image. You're going to select the card. If it's not already selected, you see that it's selected. Click on Flash, and it will flash it. But we're not going to do it because I'm actually doing it on the other one already. So once it's flashed and completed, there it is. I was wondering where it was. So there it is uploading. So while it's uploading, and you guys should be probably doing the same, do you guys have any questions on formatting the micro SD card or installing? let's see. Okay, so okay. So semi-new, so it looks like, so isn't it just as useful to pull the card from the device and use a card reader connected to your computer? So if it's a new installation, you need to do this process, yeah. And if it's upgrading, it's easier to do through the FPP device. And the developers actually, in the past, when they were upgrading branches and there was some major upgrades, you had to pull the card each time, reformat it, and install the new version. But they recently added what's called an FPP OS upgrade, where it'll upgrade the operating system in place. So the old days of having to pull the SD card out for major upgrades is pretty much a thing of the past. Now they might run across somewhere down the road where that FPP OS is not a possibility, but it's not anticipated. So you can almost always upgrade in place. But one thing to be aware of is that some of the upgrades, you can do a partial upgrade by just clicking the update, but you're not going to get the operating system upgrade. So you'll have to do the FPP OS. Sometimes the FPP OS upgrade will take a lot longer than it would be to pull the SD card out, format it, install the new one in it, and keep going. So a lot of times it's quicker and easier just to do the full install. And especially with the FPP Connect now, where it basically will upload your controller configuration, all the files that you need, and everything else. It's such a quick process that pulling the SD card out and reformatting sometimes is just a simple process. Okay, so now we have the image. So now we're ready to install FPP under the device. So put the card into your FPP device. Make sure it's fully seated. Some devices are friction only, but some are a click lock type. So make sure that they're locked in place. Get your FPP device in the area that you're going to install it with the power supply and/or cables that you'll need, but don't apply the power yet. Also make sure that you have any network adapters installed that you'll need to configure for your networking environment, like a Wi-Fi, USB, or Ethernet adapter. We're going to go through each installation method step by step, and please don't try to work ahead, because there's some things that if done in the incorrect order can make things a little more difficult to continue. So I'll give you guys a little bit of time to get that in place. Let me get rid of this. So is anybody doing the USB tethering method that is not ready? Okay, so we'll start with the USB tethering method. This is a very simple and convenient method for the devices that support it. The Raspberry Pi Zero and all of the BeagleBone-based controllers, like the Culp Lights controllers, support USB tethering, and it's a very easy installation method. For those not using the USB tethering method, hang tight, we'll be with you in a little bit. So at this point, connect your FPP device to your computer using the appropriate USB cable. Go ahead and connect them now. The FPP devices don't all use the same connector. Some are a mini USB, some are micro USB, and some are USB-C. So you'll have to have the correct cable. Also make sure that you're using a true USB cable. Like I mentioned, there's a lot of devices out there that use USB cables for charging the battery. So there's a ton of cables floating around that are designed for charging only, but they look exactly the same as a true USB cable. Someone posted, should the Beagle be removed from the cape? Normally it will work with the cape installed, but sometimes it won't. So if you can do it with the cape installed, go ahead and try it. And if it's installing, you'll see the 3 or 4 status lights blinking. If they're blinking, then you're good. You might have to press the start button to get it to work.
One thing to note there is do not power the cape from the external power while it's connected to the USB.
Correct. Only use the USB for the power.
Because if it pulls power from both places, it can sometimes fry things, and that's generally a bad thing.
Yeah. Yeah, you only want to power it from one place. So wait about a minute to let the device boot up, and then you can connect to your device through a web browser. Google Chrome is a preferred browser. Some of the other browsers might not work as well and might give you unexpected results. One of the most problematic browsers is Internet Explorer and Edge. Don't use either of those browsers for connecting to your FPP device. Once you open your web browser, let me pull mine up here. So once you open your web browser, type in the IP address that your computer uses for USB tethering. If you're using a Windows-based system, then you're going to type in 192.168.7.2. And Mac and Linux users will type in 192.168.6.2. So you should get a screen similar to this. So anybody have a problem getting to this screen that's doing the USB tethering? Okay, so don't continue until we get back to you. At this point, you guys can take a siesta because we're going to go over the other 2 installation methods. The network installation method is similar to the USB tethering method, and it's probably the most commonly used installation method because all the devices with an Ethernet adapter can be installed this way. So connect your FPP device to your network using an Ethernet cable. Make sure it's connected to an Ethernet port. Some controllers have both an Ethernet port and DMX ports. They are different. You can connect the FPP device to a port on your router or a switch connected to your router. Like I mentioned, it's not recommended to connect your FPP device directly to your computer because that requires additional network configuration on your computer. Go ahead now and connect your FPP device to an appropriate power supply. So we're going to wait about a minute to let the device boot up, and then you can connect to the device through a web browser. Like I mentioned, Google Chrome is a preferred browser. Once you open your web browser, you're going to type in, let me pull that up again. So once you open the browser, and I'll give you a little bit of time to connect it, you're going to type in http://fpp/.local/ and adding that / forces it to try and look into your local system. And you should get a screen similar to this. But I know what's going on here. And if you see, I have a problem. My other FPP device is a Pocket Beagle. And this, I have another device that's a Raspberry Pi. It's not reaching it. The reason for that is because both have the same host name, and I did not change the host name in it. It's real important that you change the host name in order to uniquely identify items. If you run across a situation like that, or a situation where you're not sure what IP addresses are, you can use advanced IP scanner, or if you already have an FPP device running with multisync, you can find the IP address on it. So with advanced IP scanner, in this case, we pull up And we've got an FPP of 192.168.1.8. And we have another one down here, FPP 192.168.7.2. 7.2 is the BeagleBone device. So we see here that the 1.8 here is the one that we actually want to get to.
Don't forget to show it in multi-sync page.
I'm going to.
Okay.
So you can see here that these are the different ones. And let's see, this is actually the new 5.0 version, just for so you can see. But if you go to the multi-sync page, you can see here all of the devices, and you can see that the 1.8 shows up down here. Now it's not going to show the one that's hooked up USB because that's on a different subnet. I could get it to show up if I wanted to configure some additional stuff down here, but I really don't want that to show up. But this here shows you that IP address. So that's two methods that you could use to get to it. So here's the one that's hooked up to the network, and this is the one that's hooked up USB tethering. So everyone that's doing the network installation, are you up to this page? Okay. You guys don't get to take a siesta because the next one's going to be real quick, but you can have a quick drink. So the Wi-Fi tethering installation, it's similar to the other methods, but it's isn't used as much because I think a lot of people don't know about it, and it's limited to the devices that support it. It is, however, the easiest way to install FPP onto a Raspberry Pi Zero, and most of the other Raspberry Pis can have the software installed this way, and it makes it a real easy way to access an FPP device if you don't want to connect it to your network. If your device does not have onboard Wi-Fi, then you'll need to install a Wi-Fi adapter, but like I mentioned, there are not many Wi-Fi adapters that support Wi-Fi tethering at this point in time. You might be better off using one of the other installation methods if your FPP device does not have an onboard Wi-Fi adapter or that you know that it doesn't support it. Like I mentioned, Culps does have the Wi-Fi adapters that support the access point. The access point is different than Wi-Fi communication. Most of the Wi-Fi adapters will support the communication, but few support the access point. Using this method requires us to connect to the access point, which means it'll disconnect us from the internet, which would be from Zoom. So we're not going to physically go through it, but I'll explain the process so that you'll know how to do it. If you need additional help, let me know at the end. So you're going to connect your FPP device to an appropriate power supply. Do not hook up any network cables to it. Leave it totally blank. You're going to wait about a minute, sometimes a couple minutes on the Pi Zeros. They take a little bit longer to boot up. And then the FPP device, it'll broadcast an access point with the host name of FPP. On Windows computers, you can access this by clicking on the Wi-Fi icon at the lower right corner of your screen. And it'll look something like this. So you can see the network icon there. So don't actually connect to it, but once you click on that, it'll pull up all of the Wi-Fi points, and there's the FPP one. So you would connect to that network, and it'll give you a message saying no internet or some other thing that makes it seem like it's not working. But once it's connected, it is, but it's not a full network connection. So once you get there, you'll type in your browser 192.168.8.1, and you get a screen similar to this. If you see, it looks just like all the other screens that we've seen so far. So then at this point, you need to complete your configuration of your network interface before you log off of the FPP network. So configure all of your networking stuff, and then we're going to go over that process in the next section. In case you want it, there's step-by-step instructions in the FPP manual if you want to see all of those as well. Someone says, what do we type in the search box? I'm not sure what you mean by a search box. If you're talking about the address bar up here, if you're using, so Jeff B, what? Tell me what you're talking about typing in the search box. If you're talking about this box, you don't use that search box. You type it in the address bar up on top. Okay, so the IP address, are you using the USB or Wi-Fi tethering? So in the Ethernet, so okay, so you're using that and you're not connected directly to your computer. If that's the case, you want to type in HTTP. So can you see that address? That should get you to where you want to go. Okay, cool. Thanks, Jeff. Okay. So everybody should be up to having the main FPP webpage. Anybody that's not to that point? Or having problems? All righty, we'll keep on rolling. Okay, so we need to complete the initial configuration of FPP so that you can use it in the show. The steps are, first you'll expand the file system, then you'll configure your network, then you'll set your time settings, then you're going to update FPP, then you're going to connect it to your final network. So when you first open the FPP page, you're going to get a screen that looks like this. Which one are we on? Let's go on to this one. Oops. I had two of the same ones open, so I want to go to this one. Okay, so if you notice a red bar at top, that's a warning, and you need to click on the link to go to the storage settings. One thing I want to make you guys aware, anytime you see a red bar or anything in red in FPP, that's usually an indication that if you do not fix this, at some point, you're probably more than likely going to have a problem somewhere. So like a lot of the people say, put the red to bed. So whatever, if it's in here, you need to take care of it. Sometimes you need to do a few other things before you continue. You can continue one by one, but sometimes you can do a couple of the things before you clear that red setting. So at this point, we're going to go to the storage settings and then grow file system. Going to ask you if you want to continue. You say yes, let it do its thing. When it's done, it's close, and then it's going to ask you to reboot. Since we're not really doing much of anything, you don't sometimes, well, let me back up a little bit. When you first install FPP, it's only going to create a partition big enough to hold the operating system. There might be a little bit of room left on there, but not a whole lot. So if you were to continue at this point without rebooting, it's possible that you're not going to get access to all of it and some of your settings won't change. So at this point, reboot. Say OK. And it'll take a little bit to reboot. So while it's rebooting, then you're going to get to, it's going to come back to the screen, it's going to reboot. But like I said, that if you don't expand that partition, I've had people have submitted support stuff where their networking configurations weren't saving, or they couldn't upload files or anything else, and they post a screenshot with that great big banner across there saying to expand the file system. So if you don't expand it, you have very little storage space available to use. So if you were using the Wi-Fi tethering method, don't click on the reboot button right then, because if you do, then it's going to log you out of the FPP network. After it reboots, you're going to have to log back into the FPP network, and then you can enter your network stuff. So if you're using just the Wi-Fi tethering, I'd suggest not doing the reboot, because there's usually enough room left just to do that little bit of configuration before you go on. Just saves you a little bit of time, but it's not, you can do it and it'll still work. Okay, so at this point, we need to configure our network correctly in order for all of our devices to be able to communicate with each other. It doesn't really matter what mode you're using. It depends on how you want to communicate with your FPP device and if you're using both networks. So you need to configure the interfaces that you're going to use. Depending on the device you're configuring, you'll either have a WLAN 0 or an ETH0 interface. Many times you'll have both interfaces. WLAN 0 is your Wi-Fi interface and ETH0 is your Ethernet or wired interface. You should define a unique host name, and if any of your interfaces are using a static address, you'll need to configure a DNS server. You guys already saw an example of why a unique host name could be a problem. You don't, like I mentioned, you don't name all your kids George unless you're George Foreman, but then it's a problem trying to get a hold of one of them to do something that you want to do. The tethering mode. So typically you'd leave the tethering mode in the default of if no connection. But if you have a specialized application, then set this accordingly. A lot of people think that that's a setting that should be done because you're not going to use tethering. That's a default setting, and it's, like I said, it's usually best to leave it as the default. So if you are going to be passing data from the WLAN 0 interface to the ETH0 interface by using a static route, then you need to enable routing between interfaces. If you're using a proxy host method of routing your traffic, then it doesn't have to be enabled. So you see this configuration here, we're only using the ETH0 interface on that FPP device. So that's the only device that you need to configure. Because that's the only device that you're configuring, then you're going to define that with all the settings, the IP, the net mask, and the gateway. For the Wi-Fi, if it has it, you just leave it as DHCP, but don't enter an SSID or password. So you could configure this as DHCP, and we'll get into that in a little bit, or set it as a static address. So this one, as you see, it's a different network configuration, but it really is the same. You're still only using an Ethernet port. It's going to a switch that ultimately connects to the router. So in this case, it's still going to be the same thing. You're going to configure the Ethernet port to have an IP address, a net mask, and a gateway. And it's going to be exactly the same as the previous one. This one is a little bit different. This one, you're using the Wi-Fi to connect to your home network. So your Wi-Fi, your WLAN 0, you're going to configure with an IP address, with a net mask, and a gateway, because the gateway you want to get to the internet. And your wireless interface is the one that's connected to that side that goes over to the internet. Your Ethernet port, you're going to give it an IP address, and that IP address has to be on a different subnet than the WLAN 0 side. It's going to have a net mask, but it will not have a gateway, because you don't want to send network traffic from your FPP device to the controllers to get to the internet. You want it to go the other way. So your gateway does not get defined on your Ethernet. So here's a typical master remote configuration. And this one is a little bit different. And we're going to go into the remotes first. So if you look at the second remote down here, we're only using Wi-Fi. We are not using an Ethernet port. There's no cables connecting it to a controller or anything. This is a CULT controller, and it's a hat-based controller, so there are no wires connecting it. It is wired internally, but there's no physical wire connecting it to a controller. So in this case, you're going to configure the WLAN 0 with an IP address. That IP address is going to be in the same subnet as your router, so it will start with 192.168.0, and then you'll define it with the number, and you want to make it a number that is not already assigned, and we'll show you how to do that in the router a little bit later. And for the ETH0, if it does have it, you could just leave it set for DHCP. It's not going to hurt anything because there's nothing connected. On the other hand, you've got the remote FPP over here, the top one. It is using both interfaces for communication. It's got the wireless side that's going to connect to your home network. So it's going to have an IP address in the same subnet. So the first three numbers are going to start off 192.168.0, the last number being the device number, to another unique number, different than everything else. Then you're going to configure the Ethernet port to access the controller. That's going to get an IP address of something that's different subnet than your network and all your wireless stuff. So you'll deem it like 192.168. something other than 0 with the device. Then your control, and it'll also have a net mask, but not the gateway. You still want your communication to go out your wireless gateway, which will take it here. So no gateway on your ETH0. Now your controller, you're going to configure with an IP address of whatever you set the subnet on the remote FPP in this instant, and we'll get into that in just a little bit. Oh, actually, I want to go back. I forgot to talk about the master. So the master, in this case, because it's only communicating through Wi-Fi, you're going to configure exactly the same as you did the one down here, with the exception of it's going to have a unique IP address. If the master had a controller connected to it, which you can, it's common to have a controller connected to it as well, you just can configure it the same as the top remote FPP that has a controller. So it's really quite simple if you just break it down to just each interface and what it's going to do. If it's Wi-Fi only, configure it with the gateway over there. If it's Wi-Fi and Ethernet, you configure the Wi-Fi to be the same as the rest, and then the Ethernet for that subnet with no gateway. Someone asked, is there an issue with using a CULT Cape controller as a master as well? Absolutely not. And with the new controllers that he has, that has the the audio capabilities, it works quite well. I actually have a couple shows that I run that are using a Culp controller before he had the audio ability, and I use it just fine as the master. So this one is very similar to the others. You're going to configure the Wi-Fi, complete Wi-Fi on that subnet. Your Ethernet is going to have the IP, the net mask, no gateway, and all of the controller and the Ethernet are all going to be on a different subnet than what your WLAN 0 device is. Are ETH0 the same for the master and the remote? Let me go back and see. So each device, and I'm assuming you're talking here. So if you were to have the master that had a controller, you would have, no, the ETH is not the same for the master and the remote. Each device has to have a unique IP address. So if you were to have more than one remote, and we'll get into this a little bit later. So in this case here, where you have the remote FPP, and I'll in a little bit later, I'm going to show a numbering scheme that'll help you keep track of things. So this remote FPP here, you would have an IP address, and we're just going to use, for example, 192.168.100.2. I'm sorry. The WLAN 0 would be 192.168.0.100. So it communicates with it. And then the ETH0 side, I would make it 192.168.100.2. So it puts it on a different subnet. And then I would put the controller would be 192.168.100.3, and it makes it real easy to understand. But it has to be unique. So on the master, say that one was 192.168.101 or 192.168.0.101, then I'd put that on a different subnet. So you're going to have basically, in this case, two different controller networks, not necessarily show network, but controller networks. And we'll get into that in a little bit more detail in a little bit. And if you have questions, let me know. Yes, the two different controllers will be different subnets. Yeah, definitely after, I'll be open for questions to guide you through what you need to do and even walk along if you need it. Okay, so when you have an FPP device that is connected to the main network via Wi-Fi, and then a controller connected via Ethernet cable, then you're going to have different subnets, like we were talking. That's why I kind of shuffled you off, because we're getting into it. So if you have multiple FPP controller combinations like this, look familiar? It'd be typical if you're using a master remote configuration with E131 based controllers, then the numbering of the subnets can get confusing. So you see that in this case, you have 4 different subnets for each FPP controller pair. So the FPP master, this controller is going to be on a different subnet. Remote 1, going to be a different subnet. Remote 2, different subnet. Remote 3, different subnet. But this only applies to E131 based controllers. Like if you're using Falcon with FPP, then you do it. If you're using the Culp controllers, there is no physical cable, so you don't need to go this route. So I use a numbering system that makes it in my mind to keep track of things, but would pick a method that works good for you. But this is kind of what I use. So if you see, all of my WLAN 0 devices are all 192.168.1. So you see the master is .1.101. My remote 1 is .1.102. Remote 2 is .1.103. Whatever it is, you know, I use the first, my main one starts with the 101, then number up sequentially from there. So what I use in deciding what the ETH0 side is going to be, I just use the device number of the WLAN 0 to be the third number for the ETH0 side, and just use a number 2. I avoid number 1 only because there are some network devices that are hard-coded to use a 1, and this avoids just any potential problem. You could use 1 if you're not using anything else, and it's not a problem. So to me, it makes it real simple. If I want to reach the controller that's connected to 192.168.1.101, then I just type in 192.168.101.3, because that's the controller IP, and it's connected through that 101. And you'll see when we get into the routing, that makes it a little bit easier as well too to identify. So 101 is the ID number. So that 101 makes the subnet for the controller network of this one to be 101. Similar for remote 1. Its device is 102, so I'll make the subnet 102, and the FPP device is .2, the controller is .3. So in my feeble mind, it's a lot less numbers to try and remember. Okay, so remember that I said a subnet is the first 3 sets of numbers in an IP address. Our home network is on one subnet, and if you have a show network or controller network, then it's going to be on, there will be on a different subnet. And if you remember, I mentioned that network traffic between different subnets is usually handled by defining proper gateways. But sometimes we need to override that default method so that we can reach our other devices. And that's a perfect example. When you want to reach your show network and controllers, you're basically going backwards in the traffic chain. You want to go down instead of up to the internet. So in order to do this, you have to create a kind of map for the devices to know how to send the traffic. That map is called a static route. You should create a route or routes for use only one of the methods. Don't try and shotgun it. If one of the methods isn't working, it's probably because you're doing it wrong. So don't try and add another one, because you could inadvertently be routing your traffic, if it's incorrect, to where none of the other methods will work. So there's 2 ways to create a static route, and then there's another way that simulates a static route. The first way is to create a static route in your router. The second way is to create a static route in your computer. And the last way that simulates a route is to create a proxy host, and that'll redirect the traffic as needed. A proxy host is a really neat tool, but it does have some drawbacks. So probably the all-around best method to route your traffic would be by creating a static route in your router. By using this method, all devices connected to your network will be able to communicate with all of your other devices. The only problem with this is that there are a few routers that do not support creating a static route. If you're using a master remote configuration or several show type controllers, then you need to create a static route for all of your FPP devices that you need to bridge that network. So let me show how to do a route in a router. I'm probably going to have to log back in. don't copy my password. So one of the big things is there is no standard on what they call it or how to get to it in a router. So if you're doing it in the router, you're probably going to have to fuddle around to try and find out where the routing is. It's usually in the advanced section somewhere, and what they call it is totally different. So you got to try and find out where it is. I think it's mine's in network. Yeah, in mine it's called advanced routing. So in here, this is the static routing section here. So I have a Pi that's connected to a Falcon controller. So my Pi is the address of my Pi, and my home network is 192.168.1 subnet. My Pi is 192.168.1.101. And my F16 is 192.168.101.3, like I mentioned following that. So what the route is the destination. You're going to enter only the subnet portion of the route that you need to get to. So my F16 is on a 192.168.101, and then you do .0. And with .0, that will send it to all devices in that. So that way you can access not only the F16, but you can access the Pi as well. And if you had a switch and connected to all the other controllers, all in that same subnet, that will hit all of them. The subnet mask almost always in consumer networks is 255.255.255.0. The default gateway, that's going to be the actual address of the device that's bridging the network. So this would be the Pi, or the Pi that is physically connected to that controller. And that is 192.168.1.101. Remember that the gateway is always going to be on the network subnet that it's on. So my router is 192.168.1.1, so the gateway has to be in that same network. You can put a description on it, and then also some routers require that you put a metric in there. You can usually put like 3, and that'll usually work. So you would enter the network. So if we were to add one, we'd do the destination 192.168.101.0, subnet mask 255.255.255.0, default gateway 192.168. And you see, by using that number, it's real easy for me to remember .1.101 because they're linked. If I'm on the subnet 101, then the device is 101. Interface is LAN, description, if I wanted to put a description in there, whatever, enable, save it. But we're not going to save it because I already got it.
Hey, Rick, can I make a suggestion? We're about an hour and a half into this 3-hour presentation, and so nobody misses anything. Do you want to take like a quick 5-minute bio break for anybody?
Actually, I have a break coming up in just after the routing section.
Oh, all right. Didn't know if you had one planned. Okay.
So no, but thanks for keeping me on track. So that's how you do a router. So then the other thing that I wanted to mention is DHCP. I mentioned that. So let me pull up the DHCP. So if you go into your DHCP settings, you can actually tell the router. Well, let me back up a little bit. What DHCP is DHCP is where it will give a device a name, which is an IP address. So if you don't set a static IP, it will just give it one. So basically a device will log onto a network and says, hey, I'm here. I don't know what you want to call me. Give me a number, and it will assign it. Or you can assign a static address where it'll always assign the same, it'll use that one. But you want to make sure that your router isn't giving out an address that is the same as what you're using. So you can go to your DHCP server, and in here, I'm telling it to assign from 2 to 99. So if a device logs onto the network, it's only going to give it an address from 2 to 99. So if I put all of my other network devices 100 or above, it'll never get a conflict with the DHCP. So now if you can't create a static route in your router, then you can create a route in your computer. There's a couple drawbacks by using this method. The first one is that you'll need to create the route on all of the computers that you want to access your show network or controllers. If you want to access your show network through your phone or other mobile device, that can be a bit complicated. If you're only connecting to your show network through a computer or one computer, then it's not much of a problem. The second issue is that Macs don't have a persistent option in the routing function. So if you reboot or power down your Mac, then you'll need to add the route again. To add a route to a Windows computer, you'll open up a command prompt by typing in CMD in the search window and then select Open as Administrator. It's important that you open as Administrator because it won't let you make changes. So let me pull up a command prompt. And so for Windows, you'll type in something like this. It's going to be route. Let me pull this down. So it's going to be route -p add, and you're going to put the destination subnet. And like I mentioned, that's similar to how you did it in the router. So it's going to be 192.168.101.0. The last number is 0, so it'll send to all devices. The mask is going to be 255.255.255.0. And then the bridging IP, which is the gateway, the device that's going to do it, is going to be 192.168.1.101. Hit enter, it'll say okay. So in this case, it told me that it failed because I already have the route in there. So that's to be expected because I did have it in there. If you want to see what routes you have in there, you can go in, do a route.print. It'll show you what persistent routes that you already have assigned. And then this is the routing table that it's using internally. The only one that you really worry about is the persistent route. For Mac computers, it's a similar process, except that you'd open a terminal window and type in the command as shown and substitute the appropriate addresses, as we mentioned, for the destination and bridging IP. People using Mac computers, I'm sorry, only kidding. I don't have a Mac computer to demonstrate on, but the process is similar. And remember, if we were using a master remote with several controllers or several controller network, then you'd have to create a static route for all of the FPP devices that had controllers connected to them through an ETH0 connection. So the last item is a proxy host. You can designate an FPP device that's bridging the networks as a proxy host to pass along the network traffic. This is a good method for people that are using Mac computers and don't have a router that supports static routes. There's a couple drawbacks with this. The first one is that if you're trying to access anything on your show network, you have to use a little bit more complicated IP address, such as this. So if you're trying to get to your controller of a 192.168.250, ooh, that's a bad address. I didn't even notice that. 225.2. Oh boy, I can't believe I screwed that up. But okay, yeah, those are bad addresses, guys. So if you're trying to access it, you have to type in a funky address like that there. You can't just type in the 192.168.250.2, but you have to type it in like that. You can use the link in FPP to get to it. Oop. So the second one is not all controllers support being accessed through a proxy host. They have to have some additional configuration so that they can use a proxy host. The Falcon controllers, if it doesn't have a more current firmware, then it cannot be accessed through a proxy host. So a proxy host in FPP would look like this. So this is my Pi that's connected to an F16. It's 192.168.101. So I want to access my Falcon controller. So I'm going to add, and you're going to type the actual address, 192.168.101.2 in this case, I believe. Save it. And now this will do it. And you can get to that controller by clicking on that link. And that will pull up your controller. You can get to it and do all of your configuration. So the proxy host is a good, powerful, quick, down and dirty way to get to it. Like I said, you just have to type that weird address to get to it. And again, if you had several devices connected, each one would have to have a proxy host to get to it. So, got any questions on overall network configuration? And we'll also take a bio break. And I will be right back and answer any questions.
John, on a Windows PC, that's what the /P was for persistent, and it should get saved.
Thank you. I appreciate that.
Okay, so somebody asked, do the routes setup through the computer get saved after the PC is turned off? So if you're using a Windows computer, it does, and that's that -P designation in there in the route -P. That -P indicates that you want it to be persistent and to save. So on Windows, it does save, but like I said, that's only for that unique computer. Any other questions? All right. So if you use an FPP, you're more than likely going to be using it for scheduling. And in order for FPP to start and stop your schedules on the correct day and time, it obviously needs to know what the current time is. So you'll need to configure your time settings on whichever FPP device is going to be responsible for the scheduling. If you have other FPP devices or remotes, they really don't need an accurate time because they're not doing anything. But for me, I like to configure it that way, but it's not mandatory. So we will go back to, let's see, we'll go back to this one. So to get to the time, you go to Status Control, FPP Settings. Then you go to the time setting. And depending on your device, it's going to have a real-time clock or not. In FPP, we'll try and detect what you have. So if you see here, this has some default ones, but it came up with the none because this one doesn't. The other one, let me go ahead and expand that really quick. Not going to reboot it at this point. And you see this one does have a real-time clock installed, and it pulled up the default. So in the time setting, you do not need to set the date or time. That is only if you're using the real-time clock portion of it. So you'd want to enable NTP, which NTP stands for Network Time Protocol. And what it does is this device will send out a request to the internet and it will return with the time. That's how your computer keeps track of the time. It does. Your computer does the same thing. If you were to disconnect it from the internet, it would eventually be way out of time. So you enable the NTP. It's going to give you the option for an NTP server. You do not need to enter one there. FPP has an internally programmed server, but some people prefer to use their own if they want. So you could do that, but you do not need to do it. The other thing is FPP needs to know where you are. I mean, the internet's huge, it's worldwide, so it needs to know where in the world you are. So you need to enter the correct time zone. So you can look through here and find where you are in all of this. But the developers actually put a neat thing. You can just look it up and it'll find where you are. The problem with this is if you're in a border area to a time zone and one of the servers where it's looking at the IP address and location, it might get you slightly off. But for the 99% of the time, it'll give you the correct location. So you just enter the NTP. Now, if your computer does not have access to the internet to get NTP, you need to have a real-time clock. And basically what a real-time clock does is when the FPP device turns off, it will keep track of what the time is that you set. If you don't have a real-time clock or the battery in the real-time clock is dead, when you power off your FPP device and power it back on, it's going to come up with a random date and time. And it's going to depend on what the device is defaulted to set for. And it's more than likely not going to be what you want. So at this point, go ahead and reboot, say okay. So at this point, you should update your FPP device. It's recommended to keep your FPP device up to date, and that way you get the most current features and bug fixes. Like I mentioned about the only time that I suggest not to update is when you're actually in the middle of a show for a holiday and everything is working correctly. But if there's some new functionality that comes out that you want to use or you're having a problem, upload the newest version first. If you're still having problems, then file a bug report, because the developers are really good about fixing bugs real quickly, especially during the show season. If you're using the USB tethering or Wi-Fi tethering method, You'll need to connect your FPP device into the network as you're going to use it, because it won't be able to connect to the network to get the update. So if you look on the Pocket Beagle here, if I go help about, if you see on this one, because I'm hooked up through USB tethering, it shows the remote get version as unknown. If the remote get version is showing unknown, that means that this device cannot get out to the internet and ultimately to GitHub. Sometimes the unknown is because you have a network configuration problem. Most often it's because your DNS server is not correct, and we're going to show how to configure that. But it would be like 8.8.8.8 should be usually the DNS server that works. So with this one, it shows here. So the local Git version, that's what is on the machine. The remote Git version, that's what is out on GitHub. It shows that it's the same. If it needed to be updated, it would show it in red. So this should get your FPP device basically up and running. There's some other presentations that'll be available on the VCS site for more information on configuring your FPP for different functionality and operation modes. Just a FYI, the developers have been putting in a ton of work on the new version 5.0, which I gave you a little preview of it here. So things are going to be a little bit different, but they'll essentially run the same. If you can, we appreciate if people were to use the master version so that we can try and work out any bugs before the season comes up. It's a pretty solid, stable interface as it is right now. And there's some interesting stats. The last couple of days, when you first install it, let me go back to the main page. When you get to the initial setup, it's going to have some stuff here that you can configure. So in one of the things is share statistics. So this is what will give information to the developers on systems that are used and all the different configurations. And it would be greatly beneficial if you enable it. It'll make their troubleshooting a lot easier, and also for enhancements, it makes it easier for them to identify what's popular things. So if you could see here in the last 7 days, let me refresh this. And this is all the data that's reported. It does not report anything personal. The developers, when they did this, spent a lot of discussion on what they wanted on there, and absolutely no way of identifying anything personal about anything. And you can even get access to the physical information that's being sent out if you're concerned. But this will show you in the last 7 days how many devices reported. The 172 came in April. March was 246. February 114. So when they last report, what platform they're using, if they're using a variant, if they're using a Pi, what model of Pi they're using, if they're using a BeagleBone, what variant, if they have capes installed, what version they're using. As you see, obviously, everyone's using the 5.0 because the 4.x master doesn't report. This shows if there's capes, so they know what capes are common out there, if they're using plugins. But there's a lot of different things you can see. Universes, a lot of good information for the developers to use. So, if you have concern, you can give you a link to go to it to ask about it. So popular settings. So any questions on the installation of FPP? That pretty much concludes what we have. So can open it up for general questions. Anyone have questions or had problems or anything like that?
Could I maybe say one thing?
Absolutely. You can say 2. That's it. Only 2.
Yeah, when you were talking about the time in FPP,
Yes.
what we have found, if you set a schedule up and you use the sunrise and sunset as your start and end times, it needs to be told your location.
Correct.
Yeah, so if you could run through that real quick.
Sure, absolutely. Yeah, I covered that in the scheduler one because that was more towards that, but I will pull.
Yeah, I think it would be a really good time to set that up, especially if you're going to go through it anyways. Yeah.
And
So
one thing to note for those of you that are on 5.0 with sunrise sunset, we're trying to track down a bug that only happens on Sundays. So today's a good day to test that out. Where the schedule doesn't click in right on the Sunday if you're using this. And unfortunately, it's very difficult, obviously, to troubleshoot because you can only troubleshoot it on Sundays unless you change your clocks and turn off NTP. So,
and that's a big hassle. But yeah, so in let me go back over. Let me actually go to the schedule. In scheduler, there's a nice function that for the start time, you can select sunrise or sunset.
you're not sharing,
Well,
or at least to the right window yet.
no, I'm not sharing. I turned it off for the general question. So let me share again.
Yeah, cool.
Okay. Back on. So on the scheduler, it's got a neat function of sunset and then an offset. For me, I don't like to start my show when it's still bright outside, but I also want it to get somewhat dark to show it. And through the season, just from Thanksgiving to Christmas, that time changes dramatically. So if I were to use a physical time, I'd have to change it. But what's called dawn and dusk, and there's different ones. There's civil, nautical, you can get into it. But for me, basically, after the physical sunset, 20 minutes after sunset is pretty much where it's dark. And this will adjust your time every day to coincide with the sunset. So it's a neat feature if you want to turn the lights on when it's at a certain darkness level outside, or even like if you're doing landscape lights and you want to turn it on when it gets done, you'd use a minus whatever, because it actually gets light before it is. But in order for this to work, it not only needs to know what your local time is, but it needs to know where the geographical location is. So in that, you go to the FPP settings, and on the system tab, this is the geographical thing. Now, before you used to have to go into Google Maps or something and find it, but they added a neat little feature to look up location, and you can look it up and it'll put in that information. This here is another instance where, like I said, on the other lookup, it might be off, but it's not to the point where the time zone, because the time zone is more granular. Because you can literally be on one side of a street and it'd be one time zone and go to the other side of the street and be in a different time zone. So if you want to find out where it is that it's showing you at, you can show on the map, and it'll pull up a Google's map and tell you where you are. And this just gives you a general location. Obviously, it's not going to be exact, but I'm right near Boise, Idaho, and that's close enough for me. Another thing is, if you want in the scheduler, if you want to use the holiday features, you have to set where you're at. Right now, they have USA and Canada. if there's people that are in different countries, if they want to get the developers a list or something of what your holidays are, that would help. And what the holidays are is like Thanksgiving. Thanksgiving isn't on a set day every year, or Easter, or there's quite a few holidays that are different like that. So if you go to the scheduler, you can actually use a holiday. So Christmas is always 12/25, so that's not a problem. But if you're to set the Christmas, you'd have to set like the certain year to start and end. But by using Christmas, it'll do every year. But you can see all of these different holidays here are pre-programmed in. So like Thanksgiving, it'll know to start on Thanksgiving, whatever the third Thursday of the month is, it'll start it.
I think that global setting, and you may know better, but I think that also sets up some of the rules for the Wi-Fi, right? For
Yes.
different power things, because in the US, it's the restrictions for power on Wi-Fi are one thing, and then in other countries, it's different.
Yeah. So Rick Baldwin says, so don't download version 5 on Sundays. No, that not so much that. Right now, there's a strange bug, and I don't think it's unique to version 5. There's a lot of people that are testing version 5, so we're seeing it there, because the scheduler stuff is, well, they redid the scheduler to be a lot more granular, so it might be just version 5, but you can download version 5, and we really would ask for you to do it, so that if you have a problem with it working on a scheduler on Sunday that's using the sunset function, if you're having that problem, then let the developers know, post it in preferably the Falcon forum, not the Facebook. Facebook is terrible for tracking things. Post it in there, and they'll probably ask you for some data on your schedule. And then that way they could try and track it down. But the problem is when they track it down, they think they have a fix. They got to wait a week to try and get that to do it again without doing a whole bunch of configuration changes and stuff. And half the time, something will kick in and then restart the NTP, and then now it ruins your whole test. So if you can, and you're not running a show or anything, thanks, Patrick. If you can, go ahead and do it, and do some testing where you have different schedules and tests where you're using the sunset function on Sunday. Maybe even do the sunrise. We haven't seen it yet, but and that's the thing is with FPP, it's so robust, and there's so many different devices, configurations, the way people do things, that there's no way for the small core of people that we have testing to put in every single different variant of a method. It could be the matter of that you have something, it could be something simple that you could have sunset on a Sunday, but the Monday schedule is overriding it, which causes a problem. And we don't know it unless we try that. So if you're not running a current schedule or show or anything, or it's not a show that's critical, you're just doing it to play around, then yeah, by all means do the 5 and have at it, and let us please try and break it. Let the developers know what's broken. That way it'll be fixed and 100% come the holidays. So any other questions?
And that bug was only when you're using sunrise, sunset on the scheduler. So it has nothing to do with you can't download on a Sunday. You can download anytime. You can upgrade it anytime you want. It's just if you're using sunrise, sunset in your schedule. And it
Correct.
only happens on Sundays.
I can go ahead and share my map now if nobody else wanted to ask a question.
All right, anybody else have questions or need help or anything like that? We got time.
I think John Earl was got it. John, you may have to get closer to your mic. We barely heard you.
How about now?
Sounds a little.
Yeah, go ahead and share your screen.
All right. So, and let's see. You guys able to see that now?
Yep.
So this is kind of my concept for this year. I actually just ordered a Culp 16 and a Culp 8 for the two controllers in there for 7 and 8. I am initially I didn't want to get too involved in the wireless because I have a very, very crowded network space, but knowing that using the master slave with the all of the sequences stored locally, I may just eliminate that network switch and make both the matrix and the Culp 40 wireless. But if I leave it in this configuration, do I have to set up static addresses for the Culp 40 and for the matrix controller?
So I take it that you're connecting your master controller via Wi-Fi to your home network.
Correct.
And then you're going to be connecting through Ethernet, and those ports that you are showing, oh no, that's correct. So, and then you're going to be connecting with Ethernet to a switch to everything else.
Just to the matrix controller and the Culp 40.
Right.
There's one more wireless that's controlling neighbors across the street.
Okay, so for the items that are going onto the Ethernet port, you will need to configure a route for that.
Okay, thanks. I will probably switch those over to wireless so I don't have to go that route. I have a Verizon Quantum router and trying to find the static route in the program or in the router has been very difficult. The only thing I found actually wanted me to include MAC addresses as well.
Yeah, well, you can do either in your computer or, like I mentioned, a proxy host to get that. There's 3 methods to do it. So if the wireless is problematic, you could use one of those other 2 routing methods. That's why they developed it. And a master remote configuration where it's communicating wirelessly doesn't use a lot of network traffic. It's very minimal. But like you said, it's congested and stuff, and there could be some potential issues there.
I may try it this way, but with the Ethernet or the wireless adapters that Dan sells at his site being like $14, I may just invest in 2 more of those.
Yeah, well, you can get the ones that Dan sells, the more expensive ones, with the antennas and stuff, those greatly increase the range and everything. I have on my show, because it was before Dan carried those, I have just an Edimax Nano on mine, and I can control my show across the street and a couple houses down with just the Edimax Nano. Now, don't get the V2s. We found that the V2s have a whole different format and don't work. Even though they say they work on Linux-based things, they're problematic. They haven't figured out what's going on with those yet. But the ones with the antennas that Dan carries definitely expands the range. And if you get the ones with the AP capability, then you can use the Wi-Fi tethering.
Any concerns about trying to control Renard controllers out of these, the AC controllers?
That I don't know.
How are you going to talk to it?
I was planning on using the differential board, differential port out of that the 8 channel, and then use one of the channels off of the Colt 40 to control one of the other ones.
Well, the K40 is only for differential expansion boards. So I don't think the Renard would be able to connect to that, because I believe the protocol on the Renards is not the same as the differential.
I'll probably take that up to the F16 then, because I know that has 2 differential ports on it.
Yeah.
What you mean is you mean
The
the
DMX
DMX ports, not
DMX,
differential
yeah.
ports. Yeah,
I thought some of these could be configured as DMX as
I believe
well.
they can actually.
Okay, I'll look at the manual on that.
I'm pretty sure. I think it's because I went and looked at that the other day, and it's on the silk screen. If you look, I'm pretty sure that. Well, I actually got one in the other room. Let me go look real quick. Look at my magnifying glass.
Actually, I got the one that I got sitting on my desk. No, it just, yeah, actually, 37 to 40, 33 to 36 are listed as DMX ports.
Yeah, they can do either or. I see the same thing.
Yeah,
Yeah.
I just saw that.
And I just started testing. So somebody sent me. I've never had a Renard board before. So somebody sent me a Renard DC board, and I've got that working fine off of a Falcon Pi cap. I have it configured. It can run off of a Falcon or an F40 off of one of the DMX ports. I had it running off of a ESP Pixel stick. What I didn't try was the F40 because didn't think of it. So, but I'm sure it'll work. Your design looks fine.
Great.
One thing I would note though, on Zoom, check your microphone input because the microphone sounds like it's in your pocket.
It's probably trying to come out of the webcam. That's the only microphone I have.
Oh, all right. It just.
Look.
Thank you, though. One other quick question on the new interface. Let me share that. So I've got a couple of curious questions here. One, I see that Rick, you had a temperature up here of Fahrenheit. How do I change that value?
Click on it.
Well, it does a switch between temp 1 and temp 2, unless I'm in the wrong place.
I believe in 5.0 there's a setting under settings for Fahrenheit versus Celsius. In 4.x you could just click on it and it would switch.
Okay. It's probably fine to leave it the way it is.
No, you could just go to settings. There's a setting in there because I saw it. Go to system. I'm guessing it's going to be there.
Oh no, it just says that doesn't do anything when I click on it.
I'll look for it while we're working with other folks, but it's because I saw it the other day.
It's under user interface, under the UI tab.
Thank you.
Oh, there we go.
There we go. It used to be you'd click on it, but I think when they added that they found they had 2 of them, they changed where it was. So.
All right. Well, I want to tell you how much I appreciate this, Rick. I wanted to tell you that everything I've learned about this started with your 2020 YouTube version of this class, and I couldn't wait to come in and actually sit through it this time. So to everybody involved, you, Patrick, Dan, thank you so much for the wonderful products first off, and then for the instruction. I couldn't have done it without you guys, so thank you.
Yeah, well, good. I'm glad that it's been a benefit. You know, and I think it's a great program and stuff, and that's why I use it for my benefit, but because now that I know a little bit more about it, I actually, decided to give back to the community and help out. So any of you guys that are in here, a great resource for you out there that I would suggest is the Zoom room. There's a few of us, and Bill can attest to, I see his name in there every once in a while, is the Zoom room for X-Lights. It's similar to this, but there's people in there usually 24/7 that are basically just in there waiting to help people out. So if you have a problem, it's a quick, easy way to get in, get your problem resolved. When it gets closer to the holiday season, it's a little more crowded. You might have to wait a little bit, but it's still a heck of a lot quicker than posting something in a forum and waiting for a couple hours or a day or two for someone to get a response. If you're not sure what the protocol is, there really isn't one. But if you get into the room and it sounds like they're helping somebody with a problem, there's an option to raise your hand. If you go down to the participants, you can raise your hand, and it basically will put you in a QE or a queue waiting to let you in. If the people are in there just BSing, because we'll be in there and there's nobody that needs any help, we'll just be talking about the weather or fishing or whatever. Just speak up and say, hey, I got a problem. Can you guys help me with it? And the people will get you through it. The people that are in there are quite knowledgeable. So it's a great tool and a great asset. I actually found out about the Zoom room before I had a single pixel or controller in my hand. I was actually looking at stuff and I had the pixels and controller ordered, and I found the Zoom room, and I just hung out there and listened every once in a while. And I learned so much about problems that people have that when I actually got my controller and pixels, that most of the problems I already knew how to resolve.
And the address for the Zoom room, if you don't remember it, if you don't have it bookmarked in Zoom, it's just go to xlights.org, and on the right hand side in the columns on the right, there's a Xlight Zoom room link. Just click on that, it'll take you over to the Zoom room.
And I think they have a link called xlightszoom.com. We'll get you there. And also, if you're in Xlights, the program itself, there's a link up there to get you to it. Okay, any other questions? Okay, I stopped my recording, so.
All right, I'm going to end the Zoom